Hello everyone. Today we talk about Eoq models. So first of all, what is the full form of Eoq model? Eoq model means economic order quantity model. So it is clear from this. This is a order model. Okay. So order model may be for retailer, for buyer, and for supplier also, but it can't be for manufacturer or producer. Okay, so today we talk about this in continuous form. Till MSc, we have done EOQ models in discrete form, EOQ and both EPQ models. EPQ like economic production quantity model, but here we will do it in continuous form. So you can see here I'm writing one question how it will come. Develop an EOQ model with constant demand. Yeah, we can say with uniform demand. So to develop and model, there are some assumptions and there are some notations. So first we write some assumptions regarding this. So it is clear from this the demand is taken as constant. So first assumption will be the demand is constant. So we can say demand rate is constant. This is only with constant demand. There is no deterioration, there is no shortage, so we can write it. Deterioration rate is not taken into consideration. Okay. Third assumption will be shortage is not allowed. Fourth one we can say lead time is zero. Okay. Now we go for notations. So we have a demand, so there is a symbol to denote the demand rate. So we say it is the demand rate. Okay. Now, if this is a order model, then there is a cost to order the quantity. Okay. So we can say that is C1. So C1 is the ordering cost. And one is Q. Q is order quantity, means how much quantity we order. So this is Q. Okay. The next one we have some inventory. So to hold that inventory, there is a cost that is known as holding cost. So we say this is C2. So we can write C2 is a holding cost per unit. And uh, there is one more which is T. This is cycle length. Means time. In how much time our stock will go to zero. Is that clear? There is any doubt regarding assumptions and notations? Okay, so we go for next, which is mathematical modeling. So the third is mathematical modeling. So first we draw the diagram. The x-axis denote the time and y-axis denote the inventory level. Yeah, we can say stock level. And there is one more notation with each inventory level. So I'm writing here IT, we can denote it by IT and we can denote it by QT. So IT is the inventory level at time T. Okay. Now we have an order. Since order quantity is Q, so suppose this is Q. Now this quantity is decreased due to the demand. Okay. So at the initial time T, the stock is Q, but if we go from 0 to T, the inventory level decreases to 0. Means at time capital T, the inventory level becomes 0. Okay. So how we develop the equation regarding this? So we know this is our inventory level and this is change continuously. So how we can write? The rate of change in inventory level is equal to this is change due to demand. So we can write it this. So this is the equation for this. It means the rate of change in inventory level is due to demand. And this is for interval 0 to T. I hope you understand. And now there is some boundary condition. So here boundary condition are at T equals 0, the inventory level is Q. And at T equals capital T, the inventory level is 0. Okay. So we can say this is equation first. Now we solve it. Okay. So we have this one dit upon dt equals minus t. Now this can be easily solved. We can write it like that d of it equals minus d of dt. Now we can integrate it. So there is one integration constant, we can say c. Now it become it equals minus dt plus c. Okay. Now we apply the boundary condition. So at t equals to t, it becomes 0. So we can write this is 0 and this will come d capital T plus c. So this implies that c equals dt. So the inventory level becomes it equals minus dt plus dt. So we can write it like that d of t minus t. So this becomes 0 to t. Now we have second boundary condition at t equals to 0, I0 is q. So it will come q equals dt. So this is our order quantity. Now there are some inventory costs. So now inventory costs are first one ordering cost, which we have taken C1, and second one is holding cost. Since the inventory is holding in the time interval 0 to t, so the limit goes to 0 to t. Okay, and the inventory level at that time is it dt. Since C2 is the per unit cost, this is the whole quantity we have to hold, and the per unit cost for holding this quantity is C2, so we can calculate that. So it will come C2 equals, and now we can put the value of it here, so it will become d of t minus t dt. Now we can easily integrate it, so it will come dt minus t square by 2. So after taking the limit, we get t square by 2. I hope it is clear to you. So now there is only two costs. So the total cost will be ordering cost plus holding cost. So here ordering cost is C2 and holding cost is, ordering cost is C1 and holding cost is C2d t square by 2. Okay. Now to find the average total cost, so we can divide it by 2. So divide it by t. So average total cost will be, we can write it like that, ATC will be 1 upon t and this total cost. Okay. So it can be written as C1 by t plus C2 dt by 2. Now our aim to find the value of t, because here decision parameter is t. Okay. And since decision parameter is single variable, so we use the concept of maxima and minima. So first we can differentiate it with respect to t. So to find the optimal value of t, we use the concept of maxima and minima. Okay. So firstly, we can say this is equation 2. So firstly, differentiate equation 2 with respect to t. Okay, so it will come dATC upon dt equal. If we differentiate it, then we get minus C1 upon t square. If we differentiate it, we get C2d upon t. Okay. Now we know that for the maximum or minimum value, we put the first derivative equal to 0 to find that value. Okay, so now we put dATC upon dt equal 0. So from here we get C1 upon t square plus C2d upon 2 equal 0. So it will come C1 upon t square equals C2d upon. So we from here we get t square equals 2c1 upon c2d. Your value of t will be, we can write here, t equals square root of 2c1 upon dc2. Okay. Now to check whether it is optimal or not, we'll find the second derivative. So now I'm writing here d2 atc upon dt square. So it will come 2c1 upon TQ, and this will become 0. We know that when we put the value of t here, we get this is greater than 0. Means total cost is minimum. And our aim is also to minimize the total cost. Okay, so that means the optimal solution, optimal value of t is t equals, we can take t star square root of 2c1 upon d seat. Okay, and second one is optimal quantity is order quantity. This is d times t. So when we put the value of t here, then we get 2c1d upon seat. So this is the complete model, economic order quantity model with constant demand. Thank you.